Hello, viewers. Welcome to the Engineering Graphics lecture series. I am Sunil Kumar. Today, in this lecture, we will discuss about the development of surfaces. This is the introductory lecture, so we will discuss the basic concept in this video. Okay, so let's begin. Development of surfaces means the unfolding of a 3D object, or we can say the uncovering of a 3D object. So there are four methods of development of surfaces. The first one is the parallel line method. This method is used for the development of prism and cylinder. And the second is radial line method. This method is used for the development of cone and development of pyramids. The third one is triangulation method. This method is used for the development of transition pieces and reducers. And the fourth one is approximate method. This method is used for the development of sphere. In our syllabus, we have only the parallel line method and radial line method problems. So, we will discuss only these two methods, parallel line method and radial line method. For the development of cylinder, we should have to use the parallel line method. So, how we can do this? Let us see this example. Suppose we have a cylinder of diameter of the base circle d and the height h. So this is a cylinder and we have to develop its surface, or we can say we have to uncover this cylinder, the lateral surface of this cylinder, not the top and base, only the lateral surface. So how can we do it? We should have to draw a horizontal line equal to this circumference of this circle. So circumference of this circle is pi into d. So draw a horizontal line of pi d and draw a vertical line equal to the height of the cylinder, which is represented by h. So this is h and this is pi d. Now make a rectangle. This is a rectangle, and this rectangle is the development of cylinder, or we can say that if we have a rectangular sheet, then by joining this vertical edge and this vertical edge, we can obtain this final shape of a cylinder. So this is the meaning of development. Second is development of prism. So look at this example. We have a pentagonal prism of suppose the edge of its base and top is represented by S. So how many faces are there in this prism, rectangular faces? This is a pentagonal prism, so the faces are 5. And these faces are having height equal to this edge, and the base is S. So we should have to draw a rectangle whose base or the horizontal line should be equal to 5 times of this edge S, because we have the 5 sides of this prism, pentagonal prism. So we have the 1 is here, 1 2 3 4 5, so it is 5s. So after the distance of s, draw a vertical line, then again take a distance of s and draw a vertical line, and this vertical length should be equal to the height of the prism. So by drawing this, you can make a development of prism. It is similar to the direction to the development of a cylinder, but the difference is this, that in the cylinder we have not drawn any vertical line in between, but here in case of prism we have drawn the vertical lines here, because these represents the um, these edges of the prism. So we can say that this is the development of a rectangle, or if we join this vertical edge with this last vertical edge together, we can obtain the prism like this. So this is the development, very simple development. Draw a horizontal line equal to 5s, draw a vertical line equal to h, and make this a big rectangle, and in this rectangle draw these vertical lines at a distance of s, and you can make the development. So these 5, 1, 2, 3, 4, 5, these 5 rectangles represent the 5 edges, the 5 sides, this side, this side, this side, so the 5 sides of the prism. The next example is development of cube. It's a simple, very simple. We know that the cube is having total 6 faces, or we can say the 4 faces, 1 base and 1 top. So these are the 4 square faces, 1, 2, 3, 4, 1 base and 1 square for top. So all these are the squares equal to the dimension of the square face of the cube. So 1, 2, 3, 4, 5 and 6. 6 squares if you draw like this, so this is the development of cube. So all these developments are made by using parallel line method. So now next move to the radial line method. For the development of cone, let us look at this example. If we have a cone of the slant height L and the base circle radius R, then we can obtain a sector of a circle as a development. How can we draw it? First of all, draw a line equal to the slant height of this cone. So this is the slant height of this cone, equal to this slant height. Draw a line here, this line. Now put your compass here and take this line as a radius and draw an arc. So what should be the angle of this sector? The angle of this sector is equal to R over L multiplied by 360 degree, where R is base circle radius and L is slant height. So by this way you can get the angle in degrees. So take this angle and draw this line. So this will be the development of cone. So this is a radial line method, because we use the slant height as a radius to draw this circle. So that's why this is a radial line method, and this is not a parallel line method, because these two lines which we join together to make a cone, this line and this line, these two lines are not parallel to each other. So this is not a parallel line method. In parallel line method, I have shown you the two lines which we can join together to form a solid are parallel to each other, but here the lines are not parallel to each other. Next is development of pyramid. So look at this example. This is a square pyramid of the base edge equal to S and the slant height equal to L. So how can we develop it? By using the radial line method. Equal to this slant edge, draw a line and then take this point as a center and open your compass equal to this length and then draw an arc, complete arc, not up to here, complete arc like this. And now on this arc, from here, from this point, cut a distance equal to the edge of the base, means equal to S. So open your compass equal to S and cut 4 times because it is a square pyramid. So 4 times we have to cut. If instead of square pyramid it's a hexagonal pyramid, then we have to take the 6 times we have to cut it. But here it is 4 edges of the base, so 4 times we have to cut. So this is first cut here, then second cut this arc here, cut the arc here, and cut the arc here. So from all these cutting points, draw a line which meets at this point, this common point. So from here, from here, from here, and from here you can join this point. So this is the development of pyramid in which we can obtain the 4 triangular faces. This is 1, this is 2nd, this is 3rd, and this is 4th. So this is the development, or we can say that by joining this last edge and this first edge together, and we use these lines as a creasing lines, these intermediate lines as crease lines, we can obtain the final shape of a square pyramid. Next example is development of frustum of cone. This is a frustum of cone in which the base circle radius of the cone is represented by capital R, and this L is the slant height of the cone, and L1 is the slant height of the cut part of the cone. So how can we do the development? It's very simple. Equal to this total slant height, draw a line. This is the line equal to L. Then take the angle theta, which is equal to R by L multiplied by 360 degree, and we know that R is the base circle radius and L is the slant height of the cone. So take the angle by calculating from here and draw this line. So we have the 2 lines. One line is this equal to L, and other line is this is also equal to L. And now open your compass equal to this complete length, and by taking this point as a center, draw this outer arc. And how can you draw this inner arc? Taking this point as a center and this distance as equal to L1, which is the cut part or the slant height of the cut part, which is equal to L1. So open your compass equal to L1 and draw this arc. So this portion is the development of frustum of a cone. Next is development of frustum of square pyramid. This is an example. Suppose we have a frustum of a square pyramid like this. L is the complete slant edge of the pyramid, and L1 is the slant edge of the cut part. So similar to the previous problem, we can solve it. First of all, take this length equal to L, or equal to the slant edge of the pyramid. Now take this point as a center and L as a radius and draw this outer arc. Okay. Now from this point, take this distance equal to L1, which is the slant edge of the cut part, and draw a one more arc like this. So we have 2 arcs. And now the third step is from this point equal to the base edge of this pyramid means equal to this edge, equal to base edge. Cut this arc and cut this arc 4 times because the base is having the 4 edges. So 1, 2, 3, 4. 4 times we have to cut it and then join this last part with this point. Similarly, open your compass at this distance, which is equal to no, there is also no need to do it. You can directly join this point with this common point, this second point with common point, this third point with common point, this fourth point with common point, all the points, and then you have to draw horizontal lines like this: 1, 2, 3, not horizontal line but straight lines, 4. So these 4 straight lines you have to draw. So it means this is the first, second, third and fourth face of this frustum of square pyramid, because frustum of square pyramid having the 4 faces: 1, 2, 3, 4. We have not developed the base, we have developed only the lateral surface. So this is the development of the lateral surface of a square pyramid. We can also practice on other types of pyramid like the pentagonal pyramid, hexagonal pyramid, triangular pyramid also. Okay, so that's all for this introductory lecture. We will discuss some problems in other video. For any question or suggestion, you may contact me at my mail ID. Thank you.